Good programming style and documentation makes a program easy to read, helps prevent errors, and makes the program easier to maintain. When we talk about programming style, we are referring to what a program looks like, not its accuracy. A program may compile and run, but have very poor style. Take as an example a program that is written on one single continuous line. This could be functionally correct, but would be horrible in style because it would be difficult to read and for all except the simplest, most trivial programs would be virtually impossible to understand. Documentation is the comments and explanation of the program. And again, a program can run correctly with poor documentation or the complete lack of documentation. However, in the case of all but trivial programs, it will be difficult to read and virtually impossible to maintain. That is why it is important that we spend some time understanding good programming style and documentation. Every program must include appropriate comments. We've already introduced how to code end-of-line comments using the double forward slash and block comments using the forward slash and asterisk pair. There's another type of comments called JavaDoc comments that begin with a forward slash and two asterisks and end with a single asterisk and a forward slash. JavaDoc comments are similar to block comments in that they can span multiple lines. However, they differ in that they can be extracted into an HTML file. We will not be using JavaDoc comments in this class, but it's worthwhile noting for the sake of completeness. Now that we know how to code comments, it's crucial that we understand what information should be included in our comments. At the beginning of every program, you should include your name, class section, instructor name, date, and a brief description of the functionality of the program. Additionally, you should include any key features, supporting data structures, and unique techniques, including any formulas used in the program. You should also include comments throughout the program to clarify. Additionally, in our class, I will require that you comment every closing brace to denote the block of code that is ending. When naming various components in your program, it is vital that you use meaningful names. The names that you choose should be descriptive and indicate the functionality. For example, a variable that represents the radius of a circle should not be named x. Naming the variable radius is far more meaningful and descriptive. In Java, we use camel case. Camel case means that the first letter of each new word in a variable name, method name, or class name is capitalized. Remember that Java is case sensitive. It's also worth noting that the first letter may not always be capitalized, as in the name of variables or the name of methods. However, every new word in that variable name or that method name will begin with a capital letter. When naming a class, we want to be sure to capitalize the first letter of the class. You will note on the slide the name of the class prime number begins with a capital P because it is a class, and the second word in the class name also begins with a capital letter, N. For methods and variables, the first letter of the variable name is prime begins with a lowercase letter, but using camel case, the second word in the variable name prime begins with a capital letter, and likewise in the method name display pattern. Use indentation and spacing to make your programs clear and easy to read, debug, and maintain. We use indentation to group blocks of code and show the relationship among program components. Each subcomponent or statement should be indented at least 2 spaces within the construct in which it is nested. Binary operators, such as the plus sign and minus sign, should have a single space added on both sides for clarity. These conventions do not affect the accuracy of our code. Java will compile programs even if all the statements are on a single line. However, that would be impossible to debug and maintain. A block is a group of code surrounded by braces. Braces denote blocks. There are two styles for using braces, the next line style and the end of line style, as shown in the diagram. The end of line style saves space and, more importantly, helps us avoid some subtle programming errors. For that reason, you will be required to use end of line style in our class. Additionally, you will be required to comment every closing brace to specify the block of code that it is ending. Inevitably, we will have errors in our programs. When a program has an error, we call it a bug. This comes from an actual bug that was found in a Mark II computer. There are three types of errors: syntax errors, runtime errors, and logic errors. Let's take a look at each of these. Syntax errors, or compile errors, are caused when we have an error in the construction of our code. That is, when the code doesn't follow the constructs of the programming language. Some examples of syntax errors include mistyping a keyword, omitting a semicolon at the end of a statement, or using an opening brace without a closing brace. Syntax errors are relatively easy to find because the compiler will tell us where they are and what causes them. Runtime errors are a bit more challenging. With runtime errors, the program compiles fine and begins to run, but terminates abnormally. Runtime errors can be caused by input errors, division by zero, or some other operation that is impossible to carry out. Logic errors are the most difficult to detect. Logical errors occur when a program compiles, runs, and gives a result. However, the result is inaccurate, or somehow the program does not perform as intended. In this program, Show Logic Errors, the logical error occurs because when we divide 9 by 5, we get an integer result. In order to correct this error, we would need to change either the 9 or the 5 to a floating point number.